Hey fourth graders, Mrs. Kramer here. We're going to do a math lesson today on adding and subtracting fractions and all operations with whole numbers and decimals. So if you think way back to earlier in the year when we practiced problem solving, that's what you're going to review today. So I am in my kitchen. I've got my apron on and I've got my cookbook here ready to help me make some chocolate chip cookies. So this is one of my favorite things to bake. And I use a lot of fractions when I make these. I have a half a cup and a quarter cup measure here. They're labeled on the handles. And if I don't have this half a cup, maybe it's dirty from using earlier, if I know how to add fractions, I know that 1/4 plus 1/4 is 2/4 or 1/2. So I can replace that. I've also got some groceries. I have some black beans and corn, some green chilies to make enchiladas for dinner. And when I went to H-E-B, I had to make sure that I knew how to add and subtract those decimals and multiply and divide when I had multiple products in my shopping cart. And it's important that I knew how to calculate that in my head so that I could be sure I was getting a fair price from the cashier when she rung me up. So make sure you pay good attention to our lesson today so that you can cook and bake and go grocery shopping on your own.
Let's practice some problems together using our problem-solving skills. First one, we have adding and subtracting fractions. So I've included over here on the side of the screen on each of our slides an anchor chart. This is what we would glue into our journals if we were in the classroom. We're not going to go over it together, but if you get stuck and you need an anchor chart, like if you wanted to go pick up your math journal, just pause the video at this part and you can use that to help you solve your problems. So Ignacio and Elaine read the same book. The shaded part of each model represents the fraction of the book that each student read. So which expression can be used to find the difference between the fraction of the book Elaine read and the fraction of the book Ignacio read? So Ignacio, he's first. I want to find the total fraction. So first I want to find the total number of parts in that whole book in this model here. When we're given a model and a problem, we definitely want to use that. It's a clue to help us solve. So I've counted 20 parts of the book. So there's 20ths, that's my denominator, and there are 13 shaded in gray. So 13 20ths is the fraction that Ignacio read. Now Elaine was reading the same book, and my model is the same size whole as Ignacio, so she's also reading 20ths, and I want to count how many she's read. I can tell that there's more gray shaded in, so it looks like Elaine has read more of the book than Ignacio. She's read 16 out of 20 parts of that book, so Elaine has definitely read more than Ignacio. Now our question down here asked us to find the difference between the fraction of the book Elaine read, so she read 16 20ths. Difference is the answer when I subtract, and the fraction of the book Ignacio read, 13 20ths. That matches answer H. Adding and subtracting whole numbers and decimals. So here's your anchor chart if you need to use it as though you had it in your math journal. The owners of a business rented 4,506 and 2,300 square feet of space in an office building. They plan to use 281 and 6/10 square feet of space for the kitchen. How many square feet of space are left? Now, when I have a word problem like this, I always like to start by modeling and drawing a picture if I'm not given one. So, do I have a total? The answer to that, if you said yes, that is correct. My total is 4,506 and 2,300 square feet in that office building. Now, I know they used part of that for a kitchen, 281 and 6/10 square feet, but I'm wondering how much is left over. So I'm missing a part. I have just modeled subtraction. So this notebook paper that I've conveniently placed on my screen here is going to help me. I've turned it 90 degrees sideways so that I can line up my place values in those lines. So I'm going to line up my decimals and drop one down into the answer so that all my place values stay lined up. Now 281, I can write in the ones, tens, and hundreds place, and the 6 is in the tenths place. So that goes underneath 2/10 from my top number. So I can fill in a 0. 6/10 is the same as 60 hundredths. So that 0 can fill in underneath the 3, and I can also fill in a ghost 0 underneath the 4 because I don't have anything in the thousands place. Now I'm ready to subtract. So now I need to regroup when there's more on the bottom or more on the floor. And my answer is a difference of 4,224 and 63 hundredths square feet. Answer F. Now we're going to solve multiplication and division problems, including interpreting remainders. I've given you a little bit of a hint with what we're going to be doing with the anchor chart I included here. Miss Wilmeth bought 4 bags of candies. Each bag contained 8 candies. She put an equal number of these candies into each of 9 gift boxes. How many candies were left over? Now leftover, that's a hint because that's the same as the remainder. So I think I'm going to be interpreting the remainder, but let's get started solving. The first step I'm going to do is, again, draw a picture. So she bought 4 bags of candies. I'm going to draw some lovely circles here to represent each of those bags. And I'm going to put 8 candies in each of those bags. I'm just going to write the number 8. I don't have to draw 8 pieces of candy, but if you're feeling creative, you could. So I have 4 groups of 8, which is a total of 32 pieces of candy. Now, Miss Wilmeth was taking that total amount of candy and she was going to put it into gift boxes. She's dividing up the 32 pieces into 9 equal groups, into 9 gift boxes containing the same amount of candy. How many pieces of candy go into each gift box? Well, I could practice using some actual pieces of candy at home. And I'm modeling a division problem. I'm dividing up 32 pieces of candy into 9 boxes. So I'm going to list my multiples of 9 over here. Now I'm using our nines trick for long division. If you are not sure what trick I'm using, if you're not familiar with this, check out the Geeky Teachy YouTube channel. There's a whole video about it, and you can learn this awesome nines trick there. So I'm going to ask myself, how many times does 9 go into 3? 9 can't go into 3, so I put a ghost 0 on top. Squish that together. How many times does 9 go into 32? Well, 36 would be going over 32, so it goes in 3 times, and 3 times 9 is 27. If I subtract, I get 5 left over, which makes sense. 5 is less than 9. So I cannot make another gift box of candies. I have 5 pieces. Now I'm ready to answer my question. Well, my quotient was 3. 32 candies divided into 9 gift boxes. But 3 is not my answer. It didn't ask how many candies go in each gift box. It asked how many were left over. I had a remainder of 5. That's my leftover. So in this case, I'm using my remainder, the red text on our anchor chart there. Strip diagrams and equations. So here's your anchor chart. If you need to refer back to it, you'll have a problem using this on your independent practice. Alexa had a total of 36 bottles of water. She drank half, so I'm going to write half as a fraction, Of the bottles of water last week, she will drink the remaining water bottles during the next 6 days. She will drink the same number of bottles each day. Which strip diagram shows a way to find W, the number of water bottles Alexa will drink during each of the next 6 days? So let's say the number of water bottles she drinks on Monday, which is going to be the same on Tuesday, Wednesday, and so on for 6 days. So I like to make my own model and then find the answer that matches best. Do I have a total in this problem? The answer is yes. She had a total of 36 bottles of water. So if I look here, this line at the bottom of the strip diagram in the options is representing the total, and W, that's not my unknown. My total is 36, so I can automatically get rid of answer A. Now, she drank half of the water bottles. If I break a chocolate chip cookie in half, I get 2 parts. So half just means divided by 2. If I divide 36 by 2, I get a quotient of 18. So I know half of 36 is 18, and she drank that half last week. So I'm going to write last so I remember there. Now my options, it could be C or D because they both show that she drank half. She drank 18 water bottles. She's drinking water bottles over the next 6 days, but she's drinking more than 6. She's drinking half, so I need to make sure that I've represented half on my diagram. Now, over the next 6 days, she'll drink this remaining half. So I know if 18 is half for last week, 18 is going to be half for this week, but she's dividing that over the next 6 days. So each day, she'll drink the same number of water bottles, represented as W. That answer is C.
All right, last problem that we're going to do is on input-output tables. Now, we read a book in class called Two of Everything, a Chinese folktale by Lily Toy Hong. And if you haven't read it, or if you want to read it again, I would highly recommend checking that out on YouTube. It's a great book about a magic pot that Mr. and Mrs. Hack-Tack find, and everything in it doubles. So its rule is ×2. In this problem, it's asking which rule shows how to find the value when given the position. My pen decided to stop working. There we go. So this table shows the relationship between the position of a number in a pattern and its value. So the position is the same as the input. The value is the same as the output. So whatever goes in has to follow a rule before it comes out. And that's what we're looking for. What rule is that? A rule can be adding, subtracting, multiplying, or dividing. So the first question I ask myself is, am I getting bigger or smaller? And in this case, from 1 to 33, 2 to 34, and so on, I'm getting bigger. So it could be addition or multiplication, definitely not subtraction or division. So I'm going to get rid of options B and C. Now, if I multiply 1 times 33 like in A, I'll get 33. 2 times 33, because the rule has to be the same for every pair of inputs and outputs. Well, 2 groups of 30 is 60, 2 groups of 3 is 6. That's not the value that I see there, so it's not multiplying by 33. I think my answer might be D, plus 32, so let's check. 1 plus 32 equals 33. 2 plus 32 equals 34. 3 plus 32 equals 35, and 4 plus 32 equals 36. Answer D. So today you reviewed all operations, adding and subtracting like fractions, 1- and 2-step problems, interpreting remainders, strip diagrams and equations, and input-output tables. Remember, to be successful, you'll need to think about if you have a total, if your numbers are getting bigger or smaller, and what operation makes sense given your labels. Now it's time for you to complete your independent practice. If you have questions, make sure you ask your teacher.